Society of Wetland Scientists webinar series. We are so glad you could join us today. My name is Jody Murray Burns, and as a volunteer with the SWS Webinar Planning Committee and a certified professional wetland scientist, moderator for today's webinar. This topic is and service, and it is being presented by Dr. Douglas Wilcox. Dr. Wilcox is a wetland ecologist who retired from the USGS in 2008 to accept a position at SUNY Brockport in his native Western New York State. He had also recently retired from his role as editor-in-chief after a 20-year tenure. His research of wetland plant communities and hydrology, including the role of climate change and the effects of lake level regulation. He was a National Joint Commission study on regulation. He was the Lake Ontario Eastern Lake Erie lead on an EPA-funded study that initiated a wetland monitoring program for all Great Lakes wetlands. His research also focused on developing wetland restoration methodologies for use in Great Lakes wetlands and implementing them in the field. He took his second retirement in 2020 and continues work on journal manuscripts relating to his research. He received the Society of Wetland Scientists Lifetime Achievement Award in 2025, and we are honored to have him as today's presenter today.
I will be talking about many of the scientific disciplines that are included in the study of wetlands and illustrate how they help develop my career. I will also try to incorporate some humor along the way. Obviously, these Society of Wetland Scientists provide the foundation for promoting the science in which my career developed. Listed here are some of the many disciplines that have been involved in my work, many with the help of collaborators. Included are studies of plants and animals, hydrology, soils, geology, remote sensing, and paleoecology. I will take you through some of my career highlights, beginning in the National Park Service, moving to the Laurentian Great Lakes, covering restoration work, studies such as on Lake Ontario that are geared toward lake level management and have political implications, and then incorporating education to train others using the knowledge that have been gained. I began my career in 1978 as an aquatic research scientist at Indiana Dunes National Lakeshore, which is now a national park. In this park, the key issues were mostly involved wetlands. Pinnock Bog in the park is a precipitation-fed ambrotrophic peatland along the path of Interstate 80 and 90. The Indiana Toll Road Commission operated an uncovered road salt storage pile adjacent to the bog for many years, eventually putting a shelter over it to protect it from the rain and to save money. However, the damage had already been done, as shown here in the dead bog vegetation and cattail invasion. And also shown on this map. However, road salt continued to enter the bog, including from culverts that directed runoff from about a half mile of highway into the bog. I conducted water chemistry and vegetation studies there and published 3 journal manuscripts, resulting in enough publicity that the storage facility was closed and the runoff rerouted. Specific conductance and other parameters were extremely high along the impacted transect into about 120 meters. Vegetation studies showed that the native bog vegetation did not appear along the transect until about 100 meters, as shown in the lower right. A few years later, I tested and implemented vegetation restoration in the impacted area. At the same time, I was conducting studies of cattail invasion at Coles Bog National Natural Landmark, which is actually a fen. I was able to conclude that the cause of cattail invasion was raised water levels due to hydrologic alterations in the watershed. When mapping the vegetation, I discovered a raised mound that had no obvious physical means of support. I then undertook groundwater hydrology studies with guidance from Bob Shudlock from the US Geological Survey. Bob taught me groundwater hydrology that I used for much of my career. The raised mound of the fen was the result of directed groundwater discharge from an underlying aquifer through a gap in the clay confining layer. Why was this an issue? The local power company was building a nuclear power plant adjacent to their coal-fired plant, right next to the park. And they were pumping groundwater from the underlying aquifer to keep the excavation dry. Our publication in Journal of Ecology illustrated the groundwater connection and threat to Coles Bog. It put a pause on construction, and the project was eventually terminated because the nuclear power plant design was no longer viable. Also, at the same time, I began studies of wetland vegetation differences in a chronosequence of dune ponds in the park, where faunal studies had been conducted by famous scientists many decades before. There are obvious changes in plant communities from younger to older rows of ponds. My published study brought about a collaboration with paleoecologist Steve Jackson, which showed that the changes in plant communities from younger to older dune ponds were due to human activities, not succession. Our paper in ecology became a textbook citation classic, debunking hydrarch succession. The National Park Service invited me to conduct a study of the effects of water level regulation on wetland vegetation in lakes at Voyageurs National Park in Minnesota. It took me 2 weeks of thinking to design a study that could show causation. I needed to sample parallel to the shore along transects that followed topographic contours with differing water level histories. It was here that I began a decade-long collaboration and friendship with the late Jim Meeker, who was an excellent plant ecologist. Our two publications provided the foundation for the management decision to change the regulation plans for the lake. Also at this time, I became editor-in-chief of the journal Wetlands and grew it from one issue per year to quarterly publication. I did the technical editing on over 1,000 published manuscripts in my 20 years as editor. But I also learned a lot about the many disciplines and types of wetlands. It was time to broaden my own research beyond the wetlands and the parks, as I had already done most of the good stuff. In 1987, I took a position at the Great Lakes Science Center, now in the U.S. Geological Survey, and I gained all of the Great Lakes as my playground. I quickly learned that the vegetation, the wetland vegetation, is greatly dependent on lake levels, which are highly variable, differ by lake, and also face pressures for regulation because other interests, such as shoreline property owners, have more money and more sway than do wetlands. Shortly after I arrived at the Great Lakes Science Center, the U.S.-Canadian International Joint Commission funded studies to evaluate options for controlling water levels on Lake Michigan-Huron, which is all one lake hydrologically. I submitted a successful proposal to study 3 wetlands using the methodology I developed at Voyageurs, sampling along transects that followed topographic contours with known lake level histories. One of those sites was Saginaw Bay on Lake Huron. The transect elevations are numbered here, and the ordination shows that this methodology sorts out plant communities quite nicely. No lake level regulation on Lake Michigan-Huron was ever implemented. I later used the Saginaw Bay data to create and publish in Wetlands a model that predicts plant communities as a function of meters above water level and number of years out of water. By this time, I was totally immersed in the relation of lake levels to vegetation, resulting in 2 often used graphics related to lake levels. One depicts changes in plant communities as lake levels recede from high to low water. The other depicts plant communities along a shoreline with respect to lake levels, going from submerged to immersion to wet meadow to shrub to forested. I also received funding from EPA to study plant communities in Arcadia Lake, a drowned river mouth wetland along the eastern shore of Lake Michigan. It holds a broad sedge-grass meadow which had been invaded by other vegetation types. Jim Meeker and I did the vegetation sampling in 3 different years and realized that the extent of sedge-grass meadow was related to land surface elevation and lake level. John Bateman and I did a photo interpretation study of vegetation types across many years with differing lake levels, as indicated by the arrows in this figure, and created a vegetation map. Kirk Kowalski and Martha Carlson Mazer used RTK GPS and boat-based depth measurements to collect innumerable topographic bathymetric data points and create a topobath map of the wetland. Lake levels tied to land elevations were able to predict the extent of such grass meadow in relation to the number of years since the last high lake level. There was much more such grass meadow in when lake levels were low and when it had been many years since the high lake level. About that time, I was inspired to create a comic relating to water levels, which I labeled From the Bog. It was published in the SWS Wetland Bulletin, later renamed Wetland Science and Practice. Over the course of 25 years, I published 100 of them. At the Great Lakes Science Center, I joined a fleet of collaborators to study several ridge and swale wetland chronosequences as part of the USGS climate change program. The Manistee Embayment is on the north shore of Lake Michigan. Beach ridges form from sand captured in embayments during high lake levels, which occur periodically during cooler climate periods. Wetlands develop in the swales between the ridges. The embayments are eventually filled, leaving a chronosequence of linear wetlands in the swales. My crew, including Jim Meeker, sampled the wetland vegetation in each swale. And I collaborated with coastal sedimentologist Todd Thompson, who is shown here vibracoring one of the beach ridges to identify the elevation of the basal foreshore, which depicts the lake level elevation when the ridge was formed. Soil scientist Aaron Archilin collected samples for optically stimulated luminescence analyses to put ages on the beach ridges. And I brought in paleoecologist Steve Jackson again to core wetlands, and he used plant macrofossil data to determine the long-term changes in vegetation from past to present. Steve Badke's crew sampled water chemistry in the field from wetlands and also from shallow groundwater wells at each beach ridge. With its Vibracore paleo lake level data from this site and several other ridge and swale sites on Lake Michigan, Todd was able to create a 4,700 year history of lake levels. It shows long-term changes of about 600 years, such as the Algoma phase, and as shown in the inset, a 160-year fluctuation pattern with a 30-year fluctuation riding within it. This is the lake level variability that drives wetland plant community development in the Great Lakes. I use groundwater chemistry data to define groundwater flow paths, coupled with Todd's geology data from the vibrocores to create a very detailed groundwater flow cross-section, and then use that hydrology and the paleovegetation data to explain the patterns of my modern day vegetation data across the chronosequence of soils. Both hydrology and vegetation papers were published in Wetlands. This was some of the best work in my career. On to wetland restoration, starting at Seney National Wildlife Refuge in the Upper Peninsula of Michigan. This is an extensive sedge fen that has been ditched and drained with flows managed to control water levels in the C3 pool on the wetland and the refuge. The primary ditch was extremely eroded, thanks to flows leaving the pool via this control structure. Kirk Kowalski and Martha Carlson Mazer on my staff joined with me to study plant communities and hydrology. The guided restoration resulted in a totally new water management system. Kerr and I also provided vegetation data to guide restoration of Metzger Marsh at Ottawa National Wildlife Refuge on the south shore of Lake Erie, where the protected barrier sand spit shown here in 1940 has been totally lost to erosion, with no littoral sediment supply available to rebuild it. Engineers designed a dike to replace the protected barrier spit and halt erosion in the interior embayment. But we included a water control structure in the design to keep the wetland hydrologically connected to the lake. Managers were concerned about allowing destructive, non-native common carp into the wetland. So we provided assistance to provide a fish access component that excludes carp but allows other fish, including northern pike, to enter. With a drawdown, the vegetation came back like gangbusters. But along with it came invasive common reed, Phragmites australis, which got both Kerr and me into the Phragmites control game. During drawdown for construction of Metzger Marsh, we found these mysterious circles in the sediment. It turns out they were made by native clams, which had been reported as totally extirpated from Lake Erie, thanks to invasive zebra mussels. Doreen Nichols on my staff did some amazing research to show how the clams were able to survive in soft wetland sediments. And she and I published the results in Nature. Back to the lake level regulation issue. The International Joint Commission was under great pressure to put further controls on Lake Ontario, where lake water levels had been regulated by the Moses Saunders Power Dam on the St. Lawrence River since 1960. See the arrow, resulting in much reduced lake level fluctuations. I got a grant to study the effects of the current regulation on wetland vegetation in 16 wetland sites, with a photo interpretation study showing loss of sedge-grass meadow, the black in the top of the figure, to cattail invasion is shown in the bottom because regulation did not allow for periodic low lake levels that would hinder cattail survival. The plant communities on heavily regulated Lake Ontario differed from those on minimally regulated Lake Superior, or where I had previously collected data. I used my Voyageurs-derived study design to sample along elevation contours and show major changes in vegetation. The hydrograph provided a means for defining elevations with specific water level histories. With the help of geographic modeler Yi Changqi, the transect elevations were used to construct models for each well and geomorphic type. Incorporating my vegetation data allowed construction of predictive models to estimate the percent of wetland in each vegetation type that would occur under any proposed new regulation plan. The model results laid the foundation for the IJC to scrap proposed Plan 2007, which would still greatly reduce structure fluctuations. They did this in favor of Plan 2014, which allows more variability. This plan is less harmful to the environment, and it was enacted and is still in play. I also found myself to be quite busy. So I decided that after 20 years as editor, that I had had enough. And my last issue of the journal came out in 2006. Earlier, I mentioned that education was needed to pass the knowledge gained along to others. So in 1998, I began teaching wetland ecology as an adjunct faculty member at the University of Michigan. It was a 3-hour class taught one evening per week in the spring semester. It was done while I was still doing my USGS day job. I later taught the course in the fall semester at the University of Michigan Dearborn. I discovered that I loved teaching, and I came up with ways to teach groundwater hydrology as well as redox, using an analogy to a Chinese buffet, so I could teach students with little hydrology or chemistry background. I also published a paper that proposed a wetland science college major. In 2008, it turns out I had had enough years in federal service to take my federal retirement, but I was now ready to hang things off. I applied for a SUNY endowed faculty position at Brockport in my native Western New York State, and about 20 miles from 3 of my Lake Ontario research sites. I then became the Empire Innovation Professor of Wetland Science. I taught wetland ecology 10 more times and also taught a follow-up course on peatlands and Great Lakes wetlands that I called Northern Wetlands, as well as restoration ecology in a seminar on scientific technical writing that made use of my editor experience. However, teaching was not the major focus of my position. I was hired to bring in external grants and fund graduate student research. In 11 years, I brought in $3 million to fund my grad students and many others for fellow faculty members in the department. This project was on restoration of sedge-grass meadow along a Lake Ontario tributary where drainage had occurred for agriculture. One of my grad students, with the help of others, did a lot of planting and seeding, resulting in some dense sedge-dominated communities. 2 other grad students conducted their research in the Lake Ontario Drowned Rivermouth wetland, where a broad sedge-grass meadow was densely dominated by cattails and then through invasion. See the dark green along the water. They developed methods for control of invading cattails by clearing the previous year's dead cattails, cutting new growth in later summer when storage compounds and rhizomes were reduced, and hand wicking recurrent growth with herbicide. This methodology has since been used at several large restoration sites. 2 other grad students provided pre and post data collection for Corps of Engineers restoration of cattail invaded Braddock Bay, where the protected barrier sand spit had been lost to erosion. My experience on Metzger Marsh and Lake Ontario provided guidance to the Corps. The Corps designed and constructed a rubble mound replacement for the sand spit and also included plans for excavating channels to provide fish access and potholes for fish, bird, and other habitat needs. Long arm excavators were used to dig the channels and potholes. And the spoils created elevated mounds that were seeded with sedge-grass meadow species. This was quite an extensive operation. In addition, cattails in Braddock Bay were caught on a large scale. An herbicide was applied to regrowth. We mapped vegetation pre and post restoration, as well as sampling pre and post restoration vegetation and post restoration fish use of the channels and potholes. Under the Great Lakes Restoration Initiative, the Environmental Protection Agency funded a large group of binational wetland scientists to develop and implement a monitoring program for all Great Lakes wetlands, at least 4 hectares in size. I secured the funding to do the Lake Ontario wetlands in the US. We collected data on vegetation, macroinvertebrates, fish, and water quality. as well as birds and amphibians. The project has been funded and continued for 15 more years, supporting dozens of grad and undergrad students. The fish sampling was great fun, and I was fortunate to see the rare black tern and catch a parent delivering a minnow to the chicks. Some of my other grad students studied invasive water chestnut, the effects of hydrofracking accident on amphibians in a Pennsylvania fen, and potential effects of climate change on wetland restorations that have been conducted on agricultural land under the USDA wetland restoration program. Back to the slide from the beginning of my presentation. All of these disciplines were involved in my career, and none of that work could have been done without the help of some very talented collaborators. So I advise you to choose your collaborators wisely. I retired again in 2020 and moved to Asheville, North Carolina, where my son is a hydrogeology professor at University of North Carolina, Asheville. But I'm still connected to SUNY and Brockport, and I continue to write and publish manuscripts. In retirement, I had the time to be able to create this book, which contains 71 autobiographical essays of about 300 words each, written by well-known folks explaining how they became wetland scientists. Thank you for listening.
Thank you, Dr. Wilcox, for this very interesting presentation. And you've done so many impressive projects. We're going to start with the Q&A now. I'm going to keep my camera off because of some bandwidth issues. But again, for our attendees, I'll be posing your questions, maybe a few of my own, that I received through the Q&A button down at the bottom to the presenter. If you forget to ask a question or have to leave before the Q&A is over, you can email the presenter at the email address listed on this slide. So let's go ahead and get started. You might have touched a little bit on this in your presentation, but what project did you find the most challenging or most rewarding in your career?
Well, the most challenging is the one that I'm working on right now. And been taking me a long time to figure it out. And it's from the rigid swale wetland that we studied on Lake Superior, where at 3 different sites, the vegetation in the swales was not the same. All the wetland chronosequences were subject to the same lake level history, but the vegetation was different. And I've been trying with little success to figure out why that is the case.
Okay. This may play into the next question may play into what you were just talking about. What project in your career have you found the most discouraging or least successful, and what lessons can you share from that experience with us? What would be the most go ahead.
Least successful.
Yes, sometimes
I
people learn from mistakes.
I don't do least successful.
Well, you have an impressive list, so very well. Here's another question. What advice would you give finding the best collaborators?
Say that again.
What advice would you give to finding the best collaborators?
Well, if you've taken wetland ecology or other hydrologic and plant ecology courses, you should know the disciplines. Trying to find the collaborators, I would suggest looking at publications, meaningful publications, and who did the exciting work, and look at the literature cited and try and contact those people.
All right. All right. Thank you. Now here's another question. One of our attendees is interested in getting your perspective of nutrient levels in the Great Lakes or Lake Erie in recent decades. Have you had a chance to keep your eye on that?
That's outside of the work that I've done.
Okay. All right. Let's see. Someone else is asking, where did you get your art training with the bog, from the bog, which I would call that educational media, nearly so on the verge of social media.
Well, I would hesitate to call it art training. Um, Having a good imagination and being able to look at things and um, copy copy um, background diagrams from things I had seen. I don't consider myself to be much of an artist.
Well, you got the ideas across. I could tell. It was good. They were pretty funny. Um, Another person asked, can older research still be published if still pertinent with up-to-date references? They're asking about, I can repeat that. Can older research?
You're conking out.
Jody, this is Roy. I could read that question, and it is, can older research still be published, is still pertinent, and include with up-to-date references? So I'm assuming that's based on some of the information that you've presented, the research that you've done. Does that make sense, what I just said?
Well, keep publishing. I've still got a list of about a dozen papers I should write, but it's difficult to get to them.
Okay. I'll give this a try. What advice do you have for students starting as ECRs in wetland ecology? I'm not sure what ECRs is myself, but
Starting when?
for students starting in wetland ecology, early career researchers, what advice would you give them?
Keep your eyes open. Most all of the research that I've done came from observations in the field, seeing things that when you're used to things being present in a certain format, certain way, and you see something that's different and immediately ask, why is this different? And let your imagination run wild.
Very good. What is one of your favorite memories that you recall in your service to SWS, since you did a lot for us?
Favorite memories in SWS are the annual scientific meetings and meeting up with people, the famous people who I really respect, and getting to know them and become friends with them.
Oh, that's great. Okay, so you had mentioned having a good imagination leading you to, being a good scientist. How has a good imagination influenced how you look at the world scientifically and how you approach complex ecological problems?
Say that again.
You look at the world scientifically and how you approach complex ecological problems. Roy, can you read that one?
Yes. It's asking about how has your good imagination influenced how you look at the world scientifically and how you approach complex ecological problems?
I think imagination comes inherently. You're either born with it or not. But the best way to invoke imagination is to be very observant when you're in the field.
Okay.
Okay. Here's another question. Where do you see the future of wetland ecology and research going? Are there certain areas of research you anticipate being significant in the next 10 to 20 years?
Climate change, climate change, climate change.
Oh, yes. Yeah. Yeah, that's a good one. Okay, here's another one. What was the experience previous to all your career activities that inspired you to work in the field of wetlands or science?
Well, when I was a kid, I was a muskrat trapper. So wetlands were very important to me. And when I was introduced to wetland problems at Indiana Dunes, I felt like I was right at home.
Nice. So, S can develop or do to encourage more experiences for young folks to get them interested in the field of wetland science?
Say that again.
Anything you thought SWS could do, program to develop to experiences for young folks to interest them in working in?
Part of that cut out.
Okay, well, let's see. We'll skip to another one unless Roy can find that question. Okay, this is a clarification of the previous one about publishing older data. As an editor, can someone, whether someone else's research from pre-2000 can still be published?
Sure.
Okay. Okay. So that's yes.
Jody,
All right, go
I
ahead.
saw, Mike, this is Roy, a co-host, I suppose you can call me today. Earlier in this talk, you had talked about hydrology and restoring the hydrology to a wetland that had failed. So I'm interested to know from your experience for sites that have already been constructed that either have too much or too little hydrology, in your experience, what you have done to modify the hydrology once the site has already been constructed. In other words, what techniques can you use to still modify the site hydrology after a site has been constructed? So, for example, I don't want to answer the question for you, but I'm not talking about soil augmentation necessarily, because then you have to do excavation. But you let me know, based on your experience, what techniques you've used to modify the site hydrology after a wetland has been restored or constructed. Over.
The best thing you can do is to try and recreate what was there before, the problems that occurred, and try to redevelop that. It's not always possible. So you try and develop methods that mimic what had been there naturally.
Okay, and where I do a lot of my work in the state of New Jersey, the Department of Environmental Protection, they do not like engineered structures. So in your experience, can you talk to the point of not having like concrete weirs when you modify site hydrology? Have you used engineered structures? And again, in New Jersey, they frown on that. The regulators do. So perhaps where you've gotten your experience that it was okay to do those kinds of structures. Could you talk a little bit about that based on your project experience? Over.
Well, ideally, if you can figure out how to um, bring back natural processes that reconstruct without hardened structures to reconstruct the functional capabilities that have been there before. As an example, the Metzger Marsh and Braddock Bay projects, if there was a way to reconstruct the natural sand barriers without hardened structure. One way to do that would be to bring back the sediment supply along the shoreline. Sediment supply had been lost because people had armored their shorelines and eliminated the erosion component that brings sediment, sand into supply, move along the shoreline that would recreate barrier beaches naturally.
Okay, thank you. Jody, you still have a hot mic? You see the next question that came in?
I think we'll call time on this and transition to our exit slides. Roy, do you mind doing the
No,
exit?
not at all. You're leading the show. Go ahead then.
Okay. All right. Well, thank you, Dr. Wilcox. We're proud to recognize our sponsors of the SWS webinar series for 2025, Davy Mitigation, SWSCA, and RES. You'll find additional information on their websites. Please visit, like, and follow our SWS webinar sponsors. This was to take advantage of our member benefits, which range from these monthly webinars, access to past webinars where you can get training certificates to apply for your WPIT or PWS certification. We have an online job board, and if you haven't visited the new website for the SWS group, you can gain access to the Career Center via the SWS member community, which is under the resources tab on the sws.org page after you put in your password. If you haven't visited it yet, you'll have to create a new password for this new website. And as you can see here, the newest ones, can you back up just a bit there, Justin? This top one is for South Central. It's with ESI, job posting. There's an assistant professorship with Syracuse University, a natural resource specialist with Oregon Department of State Lands. And then the final one is a water resource project manager. It's in the Midwest from environmental, EOC, an environmental group. You can find additional SW membership info at the SWS website. Our next webinar is going to be conducted by a group of volunteers from the Corps. They're going to be talking about recent U.S. Corps guidance, aquatic resource delineation reports, GIS mapping standards, and they're going to give us a demo of the Corps' new regulatory request system, RRS. In March, we've got an awesome professional ethics way. And then in April, the SWS Professional Wetland Certification Program is going to present on how to become a professional wetland scientist or a wetland professional in training in SPWS. There's another category too that's new. Thanks again to the exceptional presentation today, Dr. Wilcox, and to our audience for participating. Everyone have a wonderful day and stay well. Society of Wetland Scientists webinar series. We are so glad you could join us today. My name is Jody Murray Burns, and as a volunteer with the SWS Webinar Planning Committee and a certified professional wetland scientist, moderator for today's webinar. This topic is and service, and it is being presented by Dr. Douglas Wilcox. Dr. Wilcox is a wetland ecologist who retired from the USGS in 2008. to accept a position at SUNY Brockport in his native Western New York State. He had also recently retired from his role as editor-in-chief after a 20-year tenure. His research of wetland plant communities and hydrology, including the role of climate change and the effects of lake level regulation. He was a National Joint Commission study on regulation. He was the Lake Ontario Eastern Lake Erie lead on an EPA-funded study that initiated a wetland monitoring program for all Great Lakes wetlands. His research also focused on developing wetland restoration methodologies for use in Great Lakes wetlands and implementing them in the field. He took his second retirement in 2020 and continues work on journal manuscripts relating to his research. He received the Society of Wetland Scientists Lifetime Achievement Award in 2025, and we are honored to have him as today's presenter today.
I will be talking about many of the scientific disciplines that are included in the study of wetlands and illustrate how they help develop my career. I will also try to incorporate some humor along the way. Obviously, these Society of Wetland Scientists provide the foundation for promoting the science in which my career developed. Listed here are some of the many disciplines that have been involved in my work, many with the help of collaborators. Included are studies of plants and animals, hydrology, soils, geology, remote sensing, and paleoecology. I will take you through some of my career highlights, beginning in the National Park Service, moving to the Laurentian Great Lakes, covering restoration work, studies such as on Lake Ontario that are geared toward lake level management and have political implications, and then incorporating education to train others using the knowledge that have been gained. I began my career in 1978 as an aquatic research scientist at Indiana Dunes National Lakeshore, which is now a national park. In this park, the key issues were mostly involved wetlands. Pinnock Bog in the park is a precipitation-fed ambrotrophic peatland along the path of Interstate 80 and 90. The Indiana Toll Road Commission operated an uncovered road salt storage pile adjacent to the bog for many years, eventually putting a shelter over it to protect it from the rain and to save money. However, the damage had already been done, as shown here in the dead bog vegetation and cattail invasion. And also shown on this map. However, road salt continued to enter the bog, including from culverts that directed runoff from about a half mile of highway into the bog. I conducted water chemistry and vegetation studies there and published 3 journal manuscripts resulting in enough publicity that the storage facility was closed and the runoff rerouted. Specific conductance and other parameters were extremely high along the impacted transect into about 120 meters. Vegetation studies showed that the native bog vegetation did not appear along the transect until about 100 meters, as shown in the lower right. A few years later, I tested and implemented vegetation restoration in the impacted area. At the same time, I was conducting studies of cattail invasion at